Another 2 minutes will start.
Excuse me, sir.
Yes, please.
Sir, can you please shift the quiz to 6 p.m. instead of 7:30 today?
Instead of 7:30, what time?
6 p.m.
Hey, I cannot because other sections are also participating. I have already communicated.
Okay. Sir. Okay.
Today is there, no? Today, 7:30.
Yes, sir.
Yes, sir.
Okay. So today's class is basically 10-15 minutes. We will discuss with deadlock prevention. I'll not go for avoidance and detection because that is not part of this midterm syllabus. Rather, rest of the time we'll spend for discussing some previous year question, some synchronization question, and processing process scheduling. Okay, is it okay? Yes, because after midsem we can discuss this other 3 topics. So last class, if I remember correctly, we have studied what is the definition of the deadlock. So a certain processes belongs to a single set will be put into deadlock if every process is holding a resource and requesting another resource which is held by some other process belongs to the same set. Okay. So this is the deadlock prevention. So that is called as deadlock. Every process belongs to that set, must hold a resource and waiting for another resource which is held by somebody else. And that somebody else must be belongs to same set. If it is another set, then we cannot consider. Okay, can anybody say why? Why is saying that everybody has to be hold a request? That's okay, so that a cycle will not met. But why is saying that he is requesting for a process resource which is held by another process belongs to the same set? Can anybody answer why it is belongs to the same set? No. Are you able to get it? Why the definition says that it belongs to the whatever a process request for a resource, that resource is currently held by another process belongs to the same set.
Because not all the processes in a system or CPU will be in deadlock. Only those processes that will face deadlock are placed in a set.
In one sense. Another sense you can think, suppose I am holding a request, holding a resource and waiting for another resource. If it is held by some other process, then that process may execute and release that resources. Then I will never be in deadlock. I'll get that resource. But if the same process who is keeping my requested resource, if that is also belongs to my set and he is also demanding some resource which is kept by some other process, then only the deadlock comes into picture. Okay. So criteria are what? Please remember without seeing your notes. What are the different conditions for the deadlock? Yes.
The circular way.
Michael, circular way. No preemption.
Exclusion.
Mutual exclusion. And hold and wait.
Yes.
Very nice. Yes. Then we have studied how we can identify the deadlock. We have studied only one feature, that is by a resource allocation graph. And the resource allocation graph, inside the resource allocation graph, the vertices are both the processes as well as the resources. And inside this resource allocation graph, if there is any cycle, there is a possibility of deadlock. If there is no cycle, there is no question of deadlock. Okay. But can anybody tell me, if somebody will ask that, can you tell us a scenario where there is a cycle and it will guarantee that there must be a deadlock? You cannot see there maybe. In which scenario you can say that there is a cycle exists, one cycle exists among this, and there may be a deadlock. That scenario comes. Yes.
Sir, when the resource has means allocate one resource at one process at a time.
That's
then
okay.
it is guaranteed.
No, your answer should be if a resources have only single instance. If it is a multiple instance, your cycle may not plays a very important role. But if it is a single instance, एक resources है, मतलब one R1 is present, one R2 is present, one R3 is present. In that scenario, if there are cycle exist, then definitely there is a chances that the deadlock will go. Okay. If it is a single instance resources, then we studied how to handle it. So first one I discussed what is the prevention and avoidance. The prevention has to take place before the deadlock gets occurred. I have to take a preventive measure. So the preventive measure has to be considered the things by which the deadlock occurred. So by which the deadlock occurred? By four things: by a mutual exclusion, by this hold and wait, by this circular wait, and by no preemption. So what you want to do? If any one of the things will be removed or rejected, then there is a preventive measure has taken. So the first preventive measure with related to deadlock prevention can be done if any one of the condition, if any one of the deadlock condition can be prevented. Yes. So what are the first condition? The first condition is mutual exclusion. So we have to say, how can you make no mutual exclusion? Yes. So how can you apply the no mutual exclusion? Because the mutual exclusion says that every resource, the resources are mutually exclusive.
Sir, we can create multiple instances of a resource then.
Resources, no, resources are mutually exclusive. By this mutual exclusion happened, but he is saying that no mutual exclusion means he is trying to say that why don't you make the resource to be not mutually exclusive? Yes, he is saying you make the resources to be shareable. Make the resources to be shareable. So this is the solution. But can this solution will be applicable for all kind of resources? Can you make a resource to be shareable for every kind of resources? Not possible. Like a printer. A printer cannot be shareable because you cannot say that a printer is there and that printer is used by P1, P2, P3 processes at a time. Same time all processes are used. It is not possible. Since the resources, few resources are not possible, this kind of a preventive measure may not be taken place at every scenario. Yes or no? Even if one of the preventive measure is no mutual exclusion, but this no mutual exclusion has to be applied to whom? To the resources. But every resources cannot be avoided from the mutual exclusion. Like we have given an example, a printer, you cannot avoid make that printer to be shareable. which is not possible. That's why in real environment, this kind of preventive measure may not be taken. Are you getting my point? The first preventive measure. It is not possible. But the requirement is what? If you apply this preventive measure on this mutual exclusion, then resources to be shareable. But if any kind of resources can be shareable and there is no issue, it is good. But if my system is using the resources which cannot be shareable, then this kind of a preventive measure cannot be taken. Like you can say, I have to give the antibiotic is my preventive measure. And with this, it is written, the child below 5 years old cannot take antibiotic. Then what will happen? This kind of antibiotic preventive measure is only taken for the people, those who are above 5 years old. But below 5 years old, this kind of preventive measure cannot be taken. Yes, so that he is saying the first preventive measure. The second preventive measure he is saying, why don't you apply a hold and wait? Yes, he is saying the second one is no hold and wait. Very interesting this one. You will answer, huh? Hold and wait. He is saying you cannot hold a resource and waiting for another resource. Means he is saying, suppose there is three things are available. One is called as a tape drive. Another is called as, let's take hard disk. And another one is called as the printer. Yes, he is saying you apply no hold and wait. Suppose somebody has to be print something from the tape drive to the printer. Ultimately, he wants this printing. But what the system says, a tape drive cannot be directly bring it to the printer. Rather, it has to be go through this. First, it will come to the hard disk, and from the hard disk, it has to be go to the printer. Okay, this is the approach. And let's take the system as follow. Now, what this hold and wait says, you hold a resource and waiting for another resource. In that case, there is a possibility of cycle. So if I hold this and again make another request and that is held by somebody else, that's why the issue comes. Then what is saying? Don't apply the hold and wait. Don't apply the hold and wait means if you are holding something, you cannot make a request. Yes, if you are holding something, you cannot make a request. Is it possible? Why it is not? Because suppose I have hold this tape drive and hard disk. Currently, the printer is not available. Then this no hold and wait says that you cannot now make a request for the printer. Why? If you have hold this request, you cannot hold this resource, you cannot make a request. Then what I should do? Either I have to release this request, release this resources, and again requesting for the new resources, or I can say I cannot execute in this way. Then what is saying? You first release this kind of resources and again try to request for all these three kinds. But it is a tedious process. Why it is a tedious process? Already I have kept this tape drive and hard disk. But this no hold and wait saying that at that moment you cannot make a request for the printer. If you make a request for the printer by holding something, then there is a possibility of cycle. He is saying, why don't you release this one? But if I release it, the problem comes. What is the problem? The biggest problem is that the moment I release this one, somebody may take the tape drive. Some other process may take the tape drive. Then what happens? I could not get a tape drive even if I am getting the hard disk and the printer. So that's why what he's saying, this is also a very difficult scenario. But how this can be applied? The first condition can be applied when a process made a request for a resource. At that scenario, at that moment, he should not hold any other resources. This is the solution. Any other resources. This is the solution. Means he's saying when a process made a request, suppose when he is making a request, he should not hold anything. But what is the problem? The problem is, like I told, if he is holding something, he cannot make a request. Then what is the issue? The issue is unless a process occupy, just write it, then I'll explain. Unless a process occupy all the resources, he cannot start its execution. There's two things has to be done here. First is saying, if you made a request, before making a request, you should not hold anything. Means I have to newly request everything. Another is saying, unless until you keep all the resources, you cannot start its execution. If both will be applied, then both creates an issue. The first, what is the issue? The issue is that if I am holding it, I cannot make a request, then what I should do? I have to release it. The moment I should release it, I may not get these resources once again. Means the process is getting delayed. Because I have to wait for the same resource which I hold for a long period of time. And another is saying, unless until you get all these three requests, you cannot also apply this no hold and wait. So both creates a problem in different scenarios. Are you getting my point? The first one I told that if you hold something, you cannot make a request. Then what is the solution? The solution is that if you have already hold, then you release it. And again making a request for all three once again. Yes? Or another choice is that don't hold anything. First you apply for the request for all resources. Whenever you get all the resources at a time, then only you can hold it. Are you getting my point? If all three resources are available, then only you can hold it, like a chopstick. The last solution of the dining philosopher's chopstick says that if all two chopsticks are available, then only you can pick up. That is the second case he is saying. Unless until I'll get everything, all resources what I need, I cannot pick up partially. But the second one is saying, if you pick up partially, I cannot make a request. So both creates a problem. The first one creates a starvation. The second one is also delaying the problem. Why it is delayed, the second one? Because if I made a request for printer and already I occupied the tape drive and hard disk, I cannot make a request for the printer because I hold it. Then what's the solution? The solution is I have to release. After releasing these resources, again I have to reapply for all three resources. So there also the delay may comes because after I release these two resources, somebody may occupy these resources, which I cannot get it in near future. So that is called as no hold and wait. Are you getting? These are the two solutions you can apply, but both the solutions is somehow problematic. Then comes no preemption. Yes, the no preemption is simply saying that if a process demands or request for any resources, then first it has to release the resources implicitly. The existing resources. Release the already occupied resources or already assigned resources. Already assigned resources implicitly and then reoccupy once again. So what is saying? The preemption says that you have to forcibly take an away, but I cannot apply the forcibly because previously it is no preemption, means it is only preemption. So how we can make the preemption? The preemption can be done forcibly, but here it is not saying it is forcibly. He is giving a simple solution. If you want to make a request, you cannot now make a request. If you need any resource further, then implicitly you release all kind of resources what you have. Then you can apply again, reoccupy all the resources. Suppose I need A, B, and C, all three resources. Then what I'll do? Suppose I occupy this one, and then I need C. I cannot directly request for C. Rather, implicitly I'll release this A and B, and again immediately I'll start requesting for ABC. Then it is called as a preemption. So how it is avoiding them? The preemption says that immediately if I can release this A and B, that moment somebody can take it. So there is no question of a cycle comes into picture. Yes. I'm just muting. Okay. He has muted. No, thank you. Okay. Yes. So can you get the difference between the first and second? In this case, he is simply saying that you have to make a request only if this is not available. If you have occupied, you cannot make a request. Second solution he is giving that you can directly apply for all requests, all resources, provided all resources are available. But in case of preemption, he is saying that even if you occupied something, because the preemption has to be applied, you implicitly release all the resources what you have, then you can make a request for this. That is called as the preemptive rule. Then the last one is called as the no circular wait. In case of no circular wait, it is following a method called as a total ordering. Total ordering. What is the meaning of total ordering? Please look, a very nice information. So if you have a n number of resources like R1, R2, R3, like Rn, yes, all resources. So first what he does, he wrote a function f which will map any Ri to a natural number n. What he does, for every resources he mapped to a natural number n, and it is 1-to-1 basis, means there is no duplicate comes into picture. Sir. 1 minute. 1 minute. Yes. So what the total ordering says that whatever the resources you have, first you map these resources to a natural number n, and it is 1-to-1 mapping. Means every R1 will be mapped to a natural number. Let's take it is 5. Let's take it is 2. Let's take it is 6. And this is, assume it is R4 and R5. R4 is becoming 1. and R5 is becoming 3. So each resources I map to a natural number n. Then what is saying? If any process P made a request for any Ri, then this request will be granted. This request will be granted if the following condition, provided the following condition gets satisfied. Provided the following condition gets satisfied. Means what is saying? A process P made a request for this Ri. So P of Ri is allowed if what is saying? This F of Ri should be greater than the F of Rj, where for all J, all Rj, you can say all Rj held by the process P. What does it mean? Again, I'm saying this: if P, any process requesting for any Ri resource, then this will be granted provided F of Ri's value should be greater than all the resources what he has already occupied. Those numeric value should be less than this newly processes numeric value. Means what it says, suppose first I allocate P process has occupied this R2. Yes, because he does not have anything, he has occupied R2. So he has R2 with 2. Then he has requested for R3. Whether this R3 can be allocated to him or not. The R3 can be allocated provided whatever the resources he has hold, his number should be less than the newly resources number. So what is the newly resources number? 6. So this is 6. Since 6 is greater than this 2, that's why it is allocated. Yes, means R1 and R3 gets allocated. Then what he demands? Let's take after that he is requesting for R1. Now this R1 cannot be allocated. What is the reason? Because your F of R1 is 5 and this 5 is not greater than this 6. Because this 5 is greater than 2, but this 5 is not greater than 6. Because the rule says that your newly requested F of Ri should be greater than all the Rj's present with that process. What are the Rj's are present? R2 and R3. Since R2 and R3's value is 2 and 6, the 5 is not greater than 6. Since 5 is not greater than 6, that's why it cannot be allocated. So that is the rule of total ordering. I'll tell you how it is avoiding these things. Because first what is saying, every resources को आप 1-to-1 mapping कीजिए एक natural number के साथ. Then the rule applied in the very simple way. If any process made a request for a resource, that request can be granted provided his F of requested resource should be greater than F of all the resources currently available with that process P. Okay. Then the question comes, how it is avoiding this no circular weight? This is simple. If you can think about this, if I am making a P1 is making a request for R1. Yes, the R1 is considered, it is R1's value is sorry, suppose it is R2. R2's value is 6. Then he is again making a request for something called as R6, R3. The R3, first one is 2. Then R3 value is 6. Then he cannot again make a request for something which is R2. Why? The reason is that because you have occupied 2 and 6, the next value should be greater than 6. If it is greater than 6, nobody can make a request for something which is behind this. So if it is nobody can make a request behind this, then there is no question of cycle. Only you are going in an increasing manner. You cannot go back to this. So that is the procedure which is avoiding this particular circular wait. Are you getting my point? Because he is only asking in an increasing order. That's why it is called as a total ordering. So 2 is there, then he is asking for 6. If I ask something, it should be greater than 6. It cannot be less than 6. If it can be less than 6, there is a possibility of a cycle here. Suppose in my linked list, 2 is present, 6 is present, 7 is present, 9 is present. If another request will be made for less than 9, then there is a possibility of cycle. So I can say this data is already present. But if I can make a request for beyond 9, then guaranteed I cannot find a cycle with this kind of data. So that by this rule, you can avoid this total circular wait. So these are the 4 solutions they have given, but it is not more appropriate. Only last one is a nice one, but other things are more constant. Why it is more constant? The first one, as I told, the printer cannot be mutually exclusive. So this solution is not appropriate at all scenario. The second one is saying it is going to be starvation. Why it is going to be starvation? He is saying I have to wait for all resources will be available, then only I can occupy. कभी नहीं मिलेगा ऐसे scenario, ऐसे हो सकता है. And another scenario is saying if I have occupied something, I cannot make a request. Then what I have to do? Whatever I hold, that also I have to release it. If I will release these things, सोचिए already मैं tape drive से hard disk को data copy कर दिया हूँ. And then I'm waiting for the printer to take the data from the hard disk to printer. Then he is saying you cannot do like this. What to do? You have to release it. If I'll release it, what will happen? All the data, whatever I have copied in the hard disk, that may be lost also, because I have release these resources for occupying this printer once again, which is not possible. So third case it is saying I have to make it preemptive. How I can make the preemptive? I have to implicitly release the resources. Do you feel that any process, those who have occupied the resources, they are agreed to release these resources? एक बार कुछ मिल गया तो आप सोचते हो कि नहीं, जब तक वो मुझे नहीं देता है मैं रिसोर्स को नहीं छोड़ूंगा. So this is also not more applicable. So this can be somehow applicable, because when you are making a request, you are making a request for the next resource whose value is greater than all the resources what I have currently. Okay, that is the approach for this. Yes, anybody has any doubt in this? Please.
If two processes,
Huh.
sir, if two processes are having one process is having two resources, the one is 2 and one is 6, then
No, if he requires for this, he is saying first you achieve R2, then you achieve R3. If you have achieved R3 first, if he has achieved R3 first, he cannot achieve R2. What you do? He has to be free this, achieve R2, then achieve R3. Very nice question. But are you getting other people? Suppose he demands for the R2 and R3. If R2 is currently occupied by PI, he can apply for the R3 easily. But if he has got this R3 first, suppose he is using this R3 first, he cannot make a request for R2. So what to do? He has to release this R3 first, then apply for R2, get this R2, then again apply for R3 to get the R3. So that you will be assured that there is no question of circular wait comes into picture. Okay? Yes?
yes, sir.
Yes. So we'll go for some questions related to the synchronization, as I have told. So I have last time one question has come in this manner. Please look into it. One question I'll tell you. How nicely the solution has given. This kind of question, long question, first I'm saying. consider a ticket counter where the single employee is sitting to provide uh, uh, to many travelers in one by one basis. Means there is a ticket counter, there are n number of people are coming, he has to be provide the ticket one after another. Okay, at a time more than one travelers can come to the waiting hall. जैसे हम लोग टिकट काउंटर के सामने चेयर वगैरह होगा, सो वेटिंग हॉल में लोग बैठे होंगे. वन ट्रैवलर्स कैन बुक ओनली वन टिकट एट ए टाइम. एक ट्रैवलर एक ही टिकट करेगा. देयर इज ए बॉक्स, देन कैसे वो टिकट निकाल रहा है, यहां से वो बोल रहा है देयर इज ए बॉक्स सिमिलर टू बफर having unlimited number of slots where the travelers has to be put his travel request form. मतलब क्या है, एक बड़ा सा एक बॉक्स होगा, उस बॉक्स में सब लोग फॉर्म डाल देते हैं. जो बॉक्स खाली होगा उस बॉक्स में फॉर्म डाल देते हैं. मतलब सोचिए कि आपका जो रेलवे टिकट काउंटर के सामने एक एक बॉक्स होगा, उस बॉक्स में डिफरेंट सेल्स होगा, आप जैसे फॉर्म फिलअप करके एंड उस बॉक्स का एक फ्री सेल में आप डाल देते हैं. ओके, दैट इज so there is a box similar to the buffer having unlimited number of slots where unlimited numbers where the traveler has to be put his travel request form. When the box is accessed by the employee, he takes the request from one at a time. Here the employee means the counter person who is providing the ticket. He takes the request from one at a time and book the ticket based on the detail given on the request form and put the ticket in the same slot so that the corresponding traveler can collect his ticket and release the slot. Yes, मैं थोड़ा explain कर रहा हूँ. Then we'll see how interesting.
Is this problem like the producer-consumer problem? Like
nearly related to this. Suppose वो बोल रहा है कि ये आपका एक टिकट काउंटर यहाँ है, यहाँ पर एक आदमी बैठा है and there are many people are coming here. Okay, there are many persons are coming here to book the ticket. Each person will be take only one ticket at a time and there is a box present here. Okay, and what everybody will do, everybody will be find a free slot in this box and keep their ticket there, keep their form there. फॉर्म को लिख के फिलअप कर देते हैं ना, फ्रॉम टू, डेट ऑफ ट्रैवल, एवरीथिंग यू फिल अप एंड कीप इट हियर. एंड व्हाट इज दिस टिकट काउंटर्स पर्सन्स वर्क? टेक द फॉर्म, बुक ए टिकेट एंड पुट द टिकेट इन द सेम सेल where he has collect the form. Okay, so that after a ticket will be available here, the person who has kept the form here, he will collect the ticket. Got my point? Question सबको समझ में आया? Question is very important. Solution बहुत छोटा सा है. Yes? Are you getting? Everybody is getting?
Yes, sir.
हमको एक buffer भी चाहिए. Then what is saying? Now you write a function for whom? Function for the traveler and function for this employee. Yes? So कौन पहले ब्लॉक होगा? कौन पहले कंटिन्यू करेगा? कौन पहले ब्लॉक होगा?
सर फर्स्ट टाइम ट्रैवलर को एप्लीकेशन डालना होगा ना, then the
employee has to be blocked.
Yes.
Am I correct or not? This employee has to be blocked. If the employee is blocked, then I need a semaphore which is initialized with 0. Correct or not?
Yes.
Yes. So the employee needs a semaphore of a P operation through which it is going to be blocked, and initially that value should be 0. Then who has to be make it to be 1?
Traveler.
The traveler. The traveler has to be make that to be 1. So that once you put this 1, make the B operation of that semaphore, then he can easily accept it. In the same manner, the code must be written. So just see how interestingly we have written that one. Last to last time डाला था. So आप देख पाओगे. देखिए पहले ये solution मत देखिए. So पहले हम देखते हैं कि ये जो employee का, the employee has to be blocked here at this place. P counter 1 and initially the counter 1 becomes 0. दिस इज ए सीमाफोर वेयर द काउंटर 1 becomes 0. ये रह जाएगा. फिर कौन अंदर जाएगा? दिस ट्रैवलर अंदर जाएगा. एंड व्हाट द ट्रैवलर इज सेइंग, in a box there is a cell where he has to be keep the form. So जहां पर रखेगा वो फॉर्म को, वहां पर ही वो टिकट भी कलेक्ट करेगा. That's why he has taken one information called as a my ticket number, and this my ticket number is a local variable. What does it mean? For every traveler, the my ticket is a local variable, so that every traveler can remember their box cell, means where they have kept their this. Then initially the first person has to be access this box, keep the form. Second person will be access the box and keep the form. Now the question is, can everybody will be access this box at a time or one after another?
One after another.
One after
One
another.
after
Yes.
another.
That's why what he does, he put a p mutex and a v mutex here. देख पा रहे हो? He has put here p mutex and put a v mutex. What does it mean? It means that only one person can enter into this area at a time, one traveler. Yes, जो ट्रैवलर अंदर गया वो क्या किया, देखा कि मेरा कहां से बॉक्स 0 से ही वो देखना शुरू करेगा. Yes or no? Because box has a different cells and the cell numbering is from 0, 1, 2, 3. पहले वो in है 0, so 0th cell का नंबर रखा and वो बोला कि I have now kept my form in the buffer 0. Buffer 0 में उसका फॉर्म रखा and in will be plus plus. The moment in will be plus plus and he comes out from by v mutex, another traveler can easily enter into this area or not. Then what will do? He will keep this particular in with 1 and his cell number is 1. So like this, every traveler can enter, use the box with a specific cell number. Am I correct with these 3 codes or not? Forget about other code. ए सही होगा कि नहीं? अगर 5 आदमी आएंगे, एक आदमी अंदर जाएगा, इनको इंक्रीमेंट करेगा, नेक्स्ट आदमी जाएगा, इनको इंक्रीमेंट करेगा, एंड एवरी पर्सन रिमेंबर इन व्हिच सेल दे हैव केप्ट दिस देयर फॉर्म. समझ में आ रहा है?
Yes.
Yes. So once it is done, what is the next request? जितना फॉर्म यहां रखा जाएगा, based on that many tickets the employee has to be produced. Yes or no? If five passengers have kept their 5 forms, then the ticket counter person has to be give 5 tickets. But initially count 1 is 0. ये तो यहाँ पर फंस गया था. Then what he has to do? Every time a person keep the tickets and come out, he has to make the count to be plus plus. How he is making the count to be plus plus? By v count. हो पाएगा कि नहीं? By v count,
Yes,
he is plus. So if there is a 3 persons have kept their ticket, then the count is goes to 3. If count goes to 3, I have written a while loop here. Then how many times he can enter into this area, this p area? 3 times or not? Am I correct or not? If count value has incremented to 3, this while loop, this area will be entered by how many times? 3 times or not?
Yes, sir.
Yes. So he has booked the ticket. टिकट किया बुक. वो किस बेसिस पे बुक टिकट कर रहा है? उसके लिए वो एक आउट ले लिया. वो क्या कर रहा है? बॉक्स का सामने जिसका टिकट है उसको वो ले रहा है. समझ पा रहे? So in the first cell, whichever the form is present, that form he is taking. So that's why what he is saying, he is making the out form. Out में वो टिकट बुक किया and उसी out में वो रखा, and then after out is incrementing. But after he is keeping this ticket, then only the person who has kept the form, he has to be receive the ticket or not. समझ पाए? आप अगर देखेंगे यहाँ पर ये बुक, यहाँ पर वो फॉर्म रखा. फॉर्म रखने के बाद इसको बता दिया कि you please go there and he has incremented. Because of this increment, this employee can book the ticket. if the employee can book this ticket, now he can book it and kept in the same cell of that box, then he has to be intimated to him that I have kept it. How will intimate it? That is a very important question. How he can intimate it? So what he does, after he has kept this form, he has to wait for his ticket. How will wait? He has created a semaphore array. Initially, the semaphore array for each cell, a semaphore array will be created. And inside this each cell, the 0 will be there. Means even if he has kept the form there, but he cannot go further unless until somebody will be make the sum of something to be 1. Then वो क्या किया? The moment he has booked the ticket, वो ticket को वो cell में रखेगा. Then immediately he has increased this sum of that cell to be 1. So जब 1 कर देगा, then he has received it. Then he can go inside and do this. हाँ बोलिए.
सर इधर हम लोग वो भेजेंगे ना, P of SAM भेजेंगे.
नहीं, P of SAM भेजने से तो ये P of SAM को काम करेगा, क्योंकि ये P of SAM के हिसाब से वेट किया है, क्योंकि फॉर्म तो डाल दिया, टिकट नहीं मिला है, मींस ही हैज टू वेट हियर और नॉट. समझ पा रहे हो? यहाँ पे फॉर्म डाल दिया, जब तक वो टिकट प्रिपेयर नहीं कर देता तब तक आप तो नीचे जाके बाहर नहीं जा पाओगे, आप वेट करोगे. सो वेट कैसे करोगे? थ्रू पी. भी में तो वेट नहीं कर पाओगे, हम लोग सीखे हैं, पी में ही वेट करोगे. पी में कब वेट करेंगे? जब उसका वैल्यू 0 होगा. सो ऑलरेडी इट इज 0 सेट है. सिंस इट इज ऑलरेडी 0, देन जब व्हेन this employee has booked the ticket and kept the ticket inside, that time he understood he has to be increase that 0 to 1. A1 कर दिया. If it is 1, now it is make 1 to 0 and enter into this area. Once it is entered into this area, what will do? He will get the ticket and free that block. वो ब्लॉक को फ्री कर देगा. क्यों ब्लॉक को फ्री कर देगा बोलिए? बिकॉज वो जहां पर फॉर्म रखा था वहां पर टिकट भी आ गया, एंड ही हैज कलेक्ट द टिकट. नाउ दैट एरिया बिकम्स फ्री. सो हाउ इंटरेस्टिंग इट इज. सी द सेम प्रोड्यूसर कंज्यूमर रूल, बट किसके बाद क्या लिखोगे वो इंपॉर्टेंट है, वो आपको थोड़ा प्रैक्टिस करना पड़ेगा. Are you getting my point? So this you have to do it like this. What you have to do, I'll share it now only. There are many 4 to 5 questions are there, so you don't see the solution, rather you start looking into question, write down in your own way, and let's see whether the solution is matched nearly to this or not. Because इसमें हम ज्यादा इंपॉर्टेंट नहीं देंगे. कुछ भी अगर थोड़ा सा लिख के कॉपी ना करके अगर लिख रहे हो, then if it is a 10 mark, one should get 8 marks, even if it is wrong also. This is not so easy to think and write.
Excuse me, sir.
हाँ
Sir, ऐसे type of questions में around कितना time देना चाहिए? Because it takes lot of time to get a correct or almost.
No, because writing is only 2 minutes.
No sir, not writing. I mean पूरा एक question के लिए around कितना time देना चाहिए? अगर नहीं हुआ तो छोड़ देंगे, क्योंकि मतलब थोड़ा कॉम्प्लिकेटेड है ना, मतलब समझ गया तो वो कोड तक
हार्ड, क्योंकि आपको ये तो डिफिकल्ट क्वेश्चन है. ये डिफिकल्ट क्वेश्चन है. आप अगर सोच रहे हो कि अदर क्वेश्चन
एग्जाम है,
अदर क्वेश्चन वेरी इजी है, एज ए स्टूडेंट ऑलवेज यू विल प्रेफर दैट वन. ऐसा ना आपके सामने अगर मैं भी होता तो वही करता कि नहीं. उसके बाद आप ट्राई कर सकते हो. But in some time, the interviewer may ask a questions with related to synchronization. जो बैंकिंग सेक्टर वगैरह में काम करते हैं वो लोग तो पूरा का पूरा इसके ऊपर ही इम्पोर्टेंस देते हैं. जो कोर पूरा जो डिजाइन करते हैं सिंक्रोनाइजेशन कैसे बने. सो उन लोग के लिए आपका आइडिया भी चाहिए. ऐसे मत सोचिए कि आप यहाँ पर 70 स्टूडेंट्स हो, 70 स्टूडेंट्स तो 5 या 2 का एटलीस्ट लॉजिक बहुत स्ट्रांग होगा. हम लोग से भी बोल रहा हूँ. मत सोचिए कि हमारा ही लॉजिक हमको आता है, आप लोग को नहीं आता. लॉजिक एक छोटा बच्चा का भी बहुत अच्छा होता है हमसे. सो इसीलिए दिस क्वेश्चन इफ यू कैन प्रैक्टिस, यू कैन थिंक, फील गुड. देखिए मैं क्वेश्चन कर पा रहा हूँ. सिंक्रोनाइजेशन क्वेश्चन करना इतना इजी नहीं, दैट आल्सो यू हैव टू थिंक. Yes, that's why I told. And another some big short type question, एक interesting question last time डाला गया था. कोई ये वाला देखोगे, इसका आंसर क्या होगा? हाँ, ये क्वेश्चन पूरा यहाँ है. In a uniprocessor system there are two concurrent ये लास्ट टाइम किए थे शायद, हम लोग किए थे, ये वाला सॉल्व किए थे.
नहीं सर, ऐसा क्वेश्चन तो नहीं होता कुछ.
देखिए तो ये uniprocessor system there are two concurrent processes A and B as follows. A is saying begin, मतलब start किया, wait गया, wait with a semaphore S, then read some X data, then decrease X, then signal S, and B process DI. हम लोग शायद किए थे ना जो disable interrupt and enable interrupt, नहीं किए थे क्वेश्चन.
टॉपिक पढ़ाए थे, ऐसा क्वेश्चन कुछ नहीं.
क्वेश्चन नहीं किए थे. हाँ तो फिर कर, अच्छा वाला, ये बहुत अच्छा क्वेश्चन है. सो ही इज राइटिंग ए DI कमांड टू डिसेबल द इंटरप्ट एंड EI कमांड टू एनेबल द इंटरप्ट. ओके, पहले आप देख लीजिए, सेम टाइप में लिखूंगा यहाँ पर. सो दिस इज गिवन.
सर इधर लेफ्ट शिफ्ट x once means x multiplied by 2.
लेफ्ट शिफ्ट मींस इट इज मल्टीप्लाइड बाय 2. करेक्ट, सही बोले. Left shift is multiplied by 2. Then then he is saying semaphore S is 1, unsigned int x equal to 2. Then what should be the largest value of x from all possible values of x after completion of A and B? समझ पाए क्वेश्चन?
Yes.
ए हम लिखेंगे, पेपर में लिखेंगे. अब बस देख लीजिए कि s का वैल्यू 1 है, x का वैल्यू 2 है. वो पूछ सकते हैं कि स्मॉलेस्ट वैल्यू क्या होगा एंड लार्जेस्ट वैल्यू क्या होगा, वही पूछ सकते हैं ना. प्रीवियस क्वेश्चन में शायद डिफरेंस पूछा गया है, इस क्वेश्चन में किसी को स्मॉलेस्ट पूछा गया है, और एक ऑप्शन में किसी को
मैक्सिमम. मतलब वो मिनिमम 0 होता है ना, मतलब वो नेगेटिव नहीं,
यहाँ पर नेगेटिव नहीं होगा. ठीक है ना? यस, दिस इज गिवन. सो व्हाट इज द क्वेश्चन प्लीज.
वापस चले जाएगा मैक्सिमम में.
हाँ, तो आपको अभी बोलना पड़ेगा, बस याद रख लीजिए, वेट एस रीड x इक्वल टू x माइनस 1. देन यहाँ पर हुआ रीड x, देन लेफ्ट x EI DI. हाँ, यहाँ थोड़ा लिख लेता हूँ. बोलिए, ए प्रोसेस है क्या?
हाँ सर, वो प्रोसेस ए था.
वेट एस,
हाँ वेट एस रीड x x माइनस माइनस x
minus minus
v I mean signal s then end,
then खत्म हो गया. फिर b का क्या था?
disable interrupt
disable हाँ, disable I, then read x,
then वो x left shift
x equal to x left shift 1, then
yes.
enable
interrupt then end.
Yes, and x का वैल्यू इनिशियली था 2, s का वैल्यू था 1. बस बोला गया है कि आपको भी बोलना पड़ेगा कि मैक्सिमम, और बोलिए कि क्या क्या पॉसिबल वैल्यू आ सकता है, देन हमारा हर एक क्वेश्चन हो जाएगा, है कि नहीं? इफ यू कैन टेल मी एट द एंड व्हाट इज द पॉसिबल वैल्यू ऑफ x एट द एंड ऑफ एग्जीक्यूशन ऑफ A एंड B, देन यू कैन इजीली टेल दैट सर हमारा काम भी होगा. मैं दोनों क्वेश्चन अभी शेयर करूंगा. आपका क्लास खत्म होगा तो तुरंत भेजूंगा, उसके बाद आप जाओगे. ये दोनों प्रैक्टिस कीजिएगा, 2 क्वेश्चन सेट सब लोग. आंसर भी उसमें दिया गया है, बट आई हैव नॉट शोन, आई हैव आल्सो नॉट सीन. प्लीज गो थ्रू दिस, ट्राई कीजिए, फिर मुझे बताइए. प्लीज एवरीबॉडी ट्राई. नहीं आता है फिर भी थोड़ा ट्राई कीजिए. बहुत इंटरेस्टिंग क्वेश्चन.
डिसेबल इंटरप्ट मतलब क्या बोलना चाहता है?
डिसेबल इंटरप्ट मतलब हम लोग सीखे थे क्या प्रॉब्लम होता है, बोलिए तो. इंटरप्ट और लॉक में
स्विचिंग होगा.
हाँ, नो कॉन्टेक्स्ट स्विचिंग होगा. कब कॉन्टेक्स्ट स्विचिंग होगा? फिर
इंटरप्ट जब होगा, फिर क्योंकि
एनेबल हो जाएगा. फिर
हाँ, द पर्सन हु हैज डन द डिसेबल ही हैज टू बी ओनली एनेबल द इंटरप्ट. यस और नो? देन आफ्टर ओनली अनदर पर्सन कैन स्टार्ट इट्स एग्जीक्यूशन. करेक्ट, सही बोल. व्हाट आर द पॉसिबल वैल्यूज, सो दैट हमारा चारों क्वेश्चन उसमें डायरेक्टली हो जाएगा. एक क्वेश्चन था व्हाट इज मिनिमम, एक क्वेश्चन था व्हाट इज मैक्सिमम, एक क्वेश्चन था व्हाट आर द पॉसिबल वैल्यूज, एक क्वेश्चन था, व्हाट इज द डिफरेंस बिटवीन मैक्स एंड मिन?
सर अगर x ऐसे पहले अगर b आएगा
लो
तो
कैलकुलेट करके मुझे बताइए। 2 मिनट देता हूं क्योंकि हमारे पास टाइम है थोड़ा, 5 मिनट 4 मिनट है। स्केड्यूलिंग का क्वेश्चन आप देख के खुद थोड़ा समझ लीजिएगा, समझ पाओगे।
सर डिसेबल इंटरप्ट एनेबल इंटरप्ट के लिए हम बोल सकते हैं कि ये पूरा प्रोसेस एटॉमिक है, क्योंकि वो मतलब जो डिसेबल करेगा वो एनेबल
मतलब ये रूल है कि एक बार अगर ये यहाँ घुस गया
तो पूरा खत्म करने के बाद
पूरा खत्म करेगा तब भी जाके और कोई आएगा नहीं।
हाँ, तो एटॉमिक जैसा कुछ बोल सकते हैं। ठीक है सर।
सर इसमें जो सिग्नल है सर हम लोग इसमें अज्यूम करें कि सिग्नल एक क्या बोलते हैं
भी ऑपरेशन,
यूजर डिफाइंड
नो ये डायरेक्टली पी एंड भी ऑपरेशन। ये पी है, सॉरी।
सर इसका ये x मैक्सिमम 2 जाएगा।
मैक्सिमम 2,
एक्स का मैक्सिमम 16 आ रहा था मेरा।
16 आ रहा है।
2 है।
अदर्स
सर min to max 4,
min to max 4, 2 and 4 वो बोल रहे हैं। Anybody else? Very nice. Others please. देखिए हर टाइम बोलता हूँ, एक भी पैसा आप कम नहीं दे रहे हो। 1 रुपया भी कम हो गया तो कॉलेज मांगता है कि नहीं हम लोग इतना नहीं लेंगे, फाइन डाल देता है। इसलिए सब लोग करना चाहिए। एक जनरल लॉजिक और कुछ नहीं। आपको क्या देखना है? वन थिंग आई विल जस्ट गिव अ हिंट दोज हु आर नॉट एबल टू डू इट। आपको कॉन्टेक्स्ट स्विचिंग कहां पर कर सकता है? कैन एनीबडी टेल मी क्विकली वेयर द कॉन्टेक्स्ट स्विचिंग कैन बी हैपन?
सर पीएस के जस्ट पहले एक बार हो सकता है, इसके पहले भी हो सकता है।
ए में कहीं हो सकता है। पहले तो छोड़ दीजिए, पहले का तो छोड़ दीजिए।
हाँ, यस सर, यस।
Because this particular lock and this particular lock has no relation. Yes or no?
Yes.
That is using a different kind of lock. This is using a different kind of lock. Only thing is that when somebody is here, nobody can enter, but context switching हो पाएगा। Yes or no? If somebody can enter into this lock area, nobody can enter, but CPU यहां जा पाएगा। बट यहां का क्या सिनारियो है? अगर कोई यहां चला गया, कोई तो यहां नहीं जा पाएगा, कॉन्टेक्स्ट स्विचिंग भी नहीं होगा। Yes or no? That is the only possible cases or no?
Yes.
Yes. So that only you have to apply it. Yes. अभी क्या है, लैब है या?
सर लैब का एक क्विज था कुछ हुआ।
कुछ 2 मिनट में खत्म कर।
हाँ सर, आप बोल दीजिए।
ओके, सो मैं बोल रहा हूँ, देखिए अब पहले देखते हैं कि ए पहले अगर घुस जाता है क्या होता है। यस, सपोज समबडी हैज एंटर हियर, क्या किया? रीड 2 किया, फर्स्ट पॉसिबल केसेस। यस, 2 किया, फिर 2 लेफ्ट शिफ्ट 1 मतलब 4 है, आपको पता होगा, सी में पढ़े होंगे। हाँ, लेफ्ट शिफ्ट दिस मींस 2 into 2 to the power 1 which is nothing but a 4 हो गया। फिर यहां आया, 4 रीड किया, 4 माइनस 3 आया, फर्स्ट आंसर 3 आया, करेक्ट है। He has entered. Now come to this. Now इफ हैज नॉट एंटर मींस बाहर है, देन ए अंदर चला जाएगा। सो अंदर जाने पर कितना पॉसिबिलिटी है सर? एक पॉसिबिलिटी, दो पॉसिबिलिटी, थ्री पॉसिबिलिटी। यस, पहला पॉसिबिलिटी में देखिए, अगर यहां कॉन्टेक्स्ट स्विचिंग करता है तो आंसर क्या आएगा? यहां अगर कॉन्टेक्स्ट अंदर चला गया फिर कॉन्टेक्स्ट स्विचिंग हो गया, देन ही इज कमिंग हियर, एंटर हियर मींस डूइंग द सेम वर्क, दैट इज 3 और नॉट। अगर यहां पे कॉन्टेक्स्ट स्विचिंग हो गया देखिए तो क्या होगा? तो सीपीयू यहां आ गया, डिजेबल्ड इंटरप्ट कर दिया, फिर रीड किया, एक्स का वैल्यू अभी भी 2 है, फिर इसको किया, एक्स का वैल्यू 4 हो गया, फिर कॉन्टेक्स्ट स्विचिंग यहां होगा। तो
सर एक्स का वैल्यू 2 क्यों होगा? वो तो 3 होना चाहिए।
3।
अच्छा राइट नहीं है ना? ओके ओके ओके।
अभी रीड अभी तक नहीं किया है ना। आर यू गेटिंग माय पॉइंट? नो नो, अगर फर्स्ट टाइम यहां गया देन इट इज कमिंग हियर, देन आंसर इज 3 और नॉट?
फर्स्ट टाइम यस।
यस, सपोज अभी भूल जाइए उसको, अभी क्या किया? सपोज पहले ए अंदर घुस गया, देन कॉन्टेक्स्ट स्विचिंग हो गया, देन क्या होगा? ए यहां आएगा, डू द वर्क, नाउ एक्स बिकम 4, अगेन रीड एक्स 4, एक्स माइनस माइनस, आंसर इज 3 और नॉट? देन सोचिए कि सर ऐसे नहीं हुआ, यहां कॉन्टेक्स्ट स्विचिंग हुआ, तो क्या होगा? देखिए अंदर आया, रीड किया, 2 किया, 2 करने के बाद कॉन्टेक्स्ट स्विचिंग हो गया। सो यहाँ पे जब कॉन्टेक्स्ट स्विचिंग होगा क्या होगा? देखिए थोड़ा, दिस इज स्टिल 2, एक्स का वैल्यू अभी भी 2 है, 2 रीड किया, 4 किया, यहां आया, जब यहां आया दिस एक्स इज बिलोंग्स टू इज लोकल वेरिएबल और नॉट?
यस सर, 2
दिस इज लोकल,
तो
एक्स माइनस क्या हुआ? 1 हुआ, देन एक्स इज ऑप्टेटेड, आंसर आया 1। आर यू गेटिंग माय पॉइंट? यस, देन अगेन सपोज यहाँ पे कॉन्टेक्स्ट स्विचिंग हो रहा था तो क्या होगा? देखिए एक्स का वैल्यू पहले रीड किया था 2, ए हो गया था क्या है? 1, ए यहाँ पर 1 हो गया था, देन कॉन्टेक्स्ट स्विचिंग हो गया। जब कॉन्टेक्स्ट स्विचिंग हो गया, रीड किया कितना? 1 इंटू दिस कितना होगा? 2, फिर 2, फिर कॉन्टेक्स्ट स्विचिंग हुआ, आंसर हुआ 2। सो व्हाट आर द पॉसिबल आंसर? 3 3 1 2। सो मीन कितना हुआ? 1, मैक्स कितना हुआ? 3। समझ पाए? ये ऑल
समझ नहीं आ रहा है, मतलब
क्या समझ नहीं आ रहा है?
देखिए सर, पहले सर देखिए डिसेबल इंटरप्ट मतलब बी प्रोसेस एग्जीक्यूट हुआ, तो एक्स का वैल्यू आ गया 4, ठीक है, तो वो उसके बाद पी से मतलब ए से एग्जीक्यूट होना स्टार्ट हुआ, तो वो एस लॉक पार करने के बाद रीड एक्स किया, तो एक्स का वैल्यू 2 रीड करेगा या 4? क्योंकि
एक्स का वैल्यू यहाँ अपडेट हो गया है ना, अपडेट हो गया मतलब 4 रीड करेगा,
4 रीड करेगा। अच्छा सर, इसका मतलब है कि ये जो
इसका
B में है
अपडेट हो गया है,
अपडेट हो गया है, तो ठीक है, वो 4 रीड करेगा।
ये जो ये आप आर्गुमेंट नहीं कर पाओगे, एक कोड से लिखा गया है, मतलब आप सोचिएगा कहीं रीड एक्स इक्वल टू वाई एंड वाई माइनस माइनस।
हाँ, पर ये तो एटॉमिक नहीं है ना, रीड के बाद भी तो एक बार कॉन्टेक्स्ट स्विच हो सकता है फिर से।
अगर रीड के बाद कॉन्टेक्स्ट, वही तो किया ना मैं, देखिए ए हुआ, ए हुआ, फिर इसके बाद लिखा गया है कि दिस इक्वल टू, देख लीजिए एक बार लिख रहा हूं, दिस इज इनडायरेक्टली रिटन एज ए, प्लीज लिसन, देयर इज योर डाउट, y इक्वल टू दिस, देन x इक्वल टू y माइनस 1। समझ पाए? अभी बोलिए, आप समझ पाओगे शायद। आप यहाँ आया, किया, 4 हुआ, फिर 4 यहाँ रीड करेगा, 4 माइनस 1 3 हुआ, आंसर ठीक आया।
4 रीड करने के बाद वो माइनस करने के बाद स्विच करेगा, मतलब वो इन द मीन टाइम स्विच नहीं कर सकता।
ये तो ऑलरेडी कंप्लीट हो गया, स्विच कहाँ पे करेगा?
नहीं, मतलब फिर से तो कॉन्टेक्स्ट स्विच हो सकता है, मतलब y इज इक्वल टू रीड x कर लिया ना, तो
y
वो
रीड x कर लिया, हाँ,
तो y में 4 आ गया,
y में 4 आ गया,
इसके नेक्स्ट लाइन में
कॉन्टेक्स्ट स्विचिंग हो सकता है,
हाँ, हो सकता है, तो b में जाएगा।
नहीं, ये नहीं जाएगा ना, ये ऑलरेडी कंप्लीटेड इट्स वर्क।
ओ अच्छा, मतलब
इज नॉट इन अ लूप, इट इज ए नॉर्मल स्टेटमेंट।
अच्छा, तो एक बार ही करेगा,
एक बार ही करेगा, ये भी एक बार करेगा, ये भी एक बार, समझ में?
अच्छा, ओ तो वो एक बार ही करेगा, पूरा पार्ट एक बार ही एग्जीक्यूट होगा। ओके
ओके
सर, देखिए एक सेकंड सर, तो ये 4 से 3 हो गया, होने के बाद क्या हुआ?
खत्म हो
सर।
ओके,
हाँ सर, y इज इक्वल टू रीड x और x इज इक्वल टू y माइनस 1 सर हम लोग ऐसे लिखेंगे ना सर, x goes to r1, r1 minus minus r1 goes to x, ऐसा मतलब
वो है, लेकिन यहाँ पर आप स्टेटमेंट को देखोगे कि ये सिंगल स्टेटमेंट है। सोचिए जो
सर r माइनस माइनस और r1 goes to x वो कंबाइंड हो जाएगा, एक साथ होगा,
वो एक साथ होगा, पूरा का काम एक साथ। सोचिए x इक्वल टू वाई माइनस 1 एक ही साथ हो रहा है। सोचिए कि इस टाइप का एक इंस्ट्रक्शन है जहां पर y x दे देने से वो माइनस भी करता है, सेट भी करता है।
और सर वो उसके बाद
उनका डाउट क्लियर नहीं हुआ।
2 और 1 के लिए वो फिर से अगर हम लोग अलग सिनेरियो लेंगे तब वो आएगा।
No, he's R1 R2, am I
अच्छा अच्छा अच्छा
clear you or not, please?
यस सर। सर मतलब अगर ऐसा दिया रहेगा तो हर कमांड को हम लोग एटॉमिक
ऐसे
करेंगे,
हर कमांड को आप एटॉमिक सोचोगे यहाँ पर, मतलब सिंगल इंस्ट्रक्शन सोचोगे। एटॉमिक तो भूल जाइए, सिंगल इंस्ट्रक्शन जैसा सोचोगे, ठीक है ना?
यस सर।
सो अभी आप समझ पाए 3 कैसा आया पहला आंसर?
3 आ गया।
फिर कहाँ का उल्ट हो सकता है? ये अंदर या यहाँ पर या यहाँ पर।
हाँ, तो बाकी 2 में तो हो जाएगा फिर, क्योंकि वो तो
यहाँ पर क्या है, आंसर वही आएगा 3।
हाँ,
लेकिन यहाँ पर रीड होने के बाद कॉन्टेक्स्ट स्विचिंग हुआ है। रीड किया 2, एक 4, x हो गया 4, बट यहाँ पे जब आया y में 2 था, सो 2 माइनस 1 फिर से 1 सेट हो गया।
अच्छा, y में 2, अच्छा ठीक है
ना? फिर यहाँ कॉन्टेक्स्ट स्विचिंग हुआ तो क्या होगा, देखिए आपका y का वैल्यू 2 आया था,
1 हो गया, ये
हो गया
तो
था,
2 हो गया आंसर। हाँ,
तो a रीड किया 1, 1 is 2, then 2 will be set, the answer आया
2। ओके सर, वो मतलब जब 1 आया तो वो रीड करने के बाद वो लोकल वेरिएबल पे स्टोर हो जाता है। ओके ओके, इसलिए समझ गया। ओके, थैंक यू, गॉट इट।
That's it. Okay, I am ending now. You have to.
Okay.
Thank you very much. I'll share it now immediately. Within 2 minutes, you'll get
Okay.
the questions. Huh? Okay, fine.
Thank you, sir.
Thank you very much.